right, so we're going to look at the answers to the homework. Here they are. I did grade problem 22B, and it looks like almost all of you, except for Emma, got it wrong. Okay, so we definitely need to look at that particular question. Some of these pictures that you were asked to draw may be a little bit different, especially when you get down to the symmetry stuff where it asks you to draw an example of certain things. So we can look at that, but go ahead and check your answers to 562. And I think we should look at question at least 22B, if not 22 altogether. So, and then page 571 was your symmetry, and I'll scroll down to show you the rest of that in just a second. You want to do 10? Sure. The first one? Yeah. Sure, I'll do 10. Let's do that. What a great idea. So, and actually 10, 11, and 12 are the only ones where you had to have a compass and a protractor to be able to do. But honestly, with question number 10, you really didn't need, because it said 90 degrees, or right, 10 numbers, 90 degrees. And you don't have to have a protractor and a compass for a 90 degree, a 180, or even a 270. Okay? Because when we're talking about a 90-degree angle, can you envision that R goes to R prime? Now, it didn't say counterclockwise, if you notice. So a lot of us might have drawn it the other way, might have gone clockwise rather than counterclockwise. But I will tell you, if they don't specify direction with these rotations, that counterclockwise is going to be the default. Okay? So if it doesn't specify one way or the other, we'll just assume counterclockwise. And if you didn't do that here, that's okay. But on the quiz that you're going to take next class, we will assume counterclockwise if not set already, okay? So that's why their R went to R prime in the counterclockwise direction. Now this is a rectangle, so it does make sense in problem number 10 if we're starting with the upright rectangle, that it actually turns out to be more of a horizontal rectangle, longer, and it's just drawn in that form. 90 degrees just means literally a right angle turn. So because it's something that we're common or we're familiar with, the 90 degrees, then that's something you don't really need to have a protractor with, because we can just use right angles, okay? Those dotted lines are not necessary for you to draw. You can just literally kind of visualize how it turned from this to this, okay? Now, how would a 180 degree turn look? If we're starting with an upright rectangle and I rotated it 180 degrees, what would actually happen? It would be upside down, right. And when it rotates 180 degrees and it ends up on itself again, what kind of symmetry is that? Do you remember? Okay, it's even more than rotational symmetry. It has rotational symmetry of 180 degrees, but it has another kind. No, it's actually point symmetry. That is what point symmetry is. When you rotate 180 degrees and you end up back on yourself, it's called point symmetry. And you need to make sure you definitely know that for your quiz next class. Okay? So a rectangle would have point symmetry. It also has rotational. It also has a line. It has a lot of them, actually. Does that answer your question? Okay, good. All right, and we said number 22 we wanted to go over as well, right? So let's look at 22. Question 22, boy, am I not going to try to draw that, but sort of. So we have this with a 1, 2, 3, 4, 5, 6, 7, 8. An 8-sided star. Can I just do an 8-sided hexagon in the middle or whatever? It was kind of a star in 2022. Ooh, pretty. Let's try to go inside a little bit more. And we're going to draw a circle just around that. Okay. Whoa. So my point is here, I'm drawing a hexagon. Why is a hexagon the same thing as a star, really? Because all we care about is the degree of rotation. Would you agree? And so the degree is going to be the same as long as it has the same amount of points. And that's what it was doing there. So this is not the exact picture for number 22, but it's a similar one. And it says find, in part A, it says find the angle of rotation about C. So C was in the middle. that maps Q to X. And so Q was going to be over here, and then X would be 1, 2, 3, 1, 2, X would be here. Okay? So for A, we're going to go from Q to X. And then for part B, which many of you didn't see, we're going to go from X to Q. Okay? Now, what we're looking at is the degree rotation. So from Q to X, if we're looking at counterclockwise here, because it doesn't specify a direction, do you agree with that? So Q to X, we're going to always look at counterclockwise if a direction isn't noted. So from Q to X, we're looking counterclockwise. How do I figure out that degree of rotation? What do I need to do? Who remembers from class? 360 divided by the number of points or sides. In this case, it would be 8, right? So 360 divided by 8. I'm going to go ahead and do that off to the side real quick. It's 45. So I get 45 degrees. So each of those little angles here is 45. How many of them did I go through? 1, 2, 3, right? Here's Q. So didn't I go through 3 of them? 1, 2, 3. Right? So 45 times 3 is 135. So from Q to X, I get 135 degrees. Now to get from X to Q, again, we're going in the same direction. We're still going counterclockwise. So we're going to go from X to Q. Well, I don't even have to count because I know that it's just going to, the total should add up to what? 360. So I know that 360 minus 135 was going to be 225. And so that was the one that I graded for extra credit there. Does that make sense? See why I'm not sure what happened there. A lot of you just didn't realize there was a B, but for those of you who did it, you do. Can I read your writing? Is that part of the problem?
That's Q to X and X to Q.
Oh, I just looked at the second one. All right. All right. I'll go back and change the grade. All right. Any other questions on this part? Rotational symmetry, okay. We'll practice a rotation actually graphing it with a compass and a protractor because you'll have to do that on your quiz next class as well. Go ahead and check your answers then for me on page 571. Let me go ahead and put those up there. I'll pause the recording while you do that. Okay, any freeform shape, they don't all have to have symmetry, but anything that's regular definitely has some kind. Well, let's look at 13. So let's go ahead. What page was that again? 571. Okay. So on page 571, number 13, what does that figure look like? 13. It was a right triangle. Okay. And that's all we're taught, right? Okay, so what did you tell me it had? You thought it was line symmetry, and you thought this was the line of symmetry? Okay. Would you agree with them? If we were told a couple of things, okay? One, we had to be told that this was a right angle and that these were congruent. It looked like it in the picture, didn't it? But to guarantee it, maybe that's why the book said none, okay? So I would venture to say you're probably right, assuming that those blue marks were on the picture, okay? If they were, then yes, I agree with you. Anything else on the homework? We're good? Would you like an opportunity at the end of class today to practice doing a rotation again with the compass and the protractor, just to make sure we know how to do it before the quiz? Okay, we'll do that. All right, what I'm going to have you guys do, and I'm sorry the tablet thing didn't work out, but they're trying to get this update going and whatever. So if some of you were able to watch it, that's awesome. But for those of us who were not able to all the way, I'm going to go ahead and go straight to the instructional portion of it. And we're going to watch just a little bit of it.
Dilation an enlargement or a reduction? What is the scale factor of the dilation? Your choices are A, an enlargement with scale factor 2, B, an enlargement with scale factor 3, C, a reduction with scale factor 1/3, and D, a reduction with scale factor 3.
Now, when I first started looking at these, I was doing them fairly quickly, and I'm like, oh, that's obviously a what? A reduction or an enlargement? It's an enlargement, because we know that the prime is what afterward, is the after effect, and so the smaller one would have been the beginning, the pre-image, then we have the image. What scale factor? Those of you who already have seen it, don't yell out the answer because you know. But right when you look at it, anyone think it was an enlargement of scale factor 2 right away? Okay, I kind of was like, oh, 8 divided by 4, done, move. Did you do that? Okay, that's a classic mistake. Okay, so let's watch out. Let's watch why that's a classic mistake. I know, the other one. We know that part.
The image is larger
Okay.
than the
We know that.
So the
This is the part that we mess up a little bit.
use the ratio of the length of corresponding sides to find the scale factor.
We're trying. Come on.
To find the scale factor n, divide the length of one side of the image, the blue triangle, by the length of the corresponding side of the pre-image, the black triangle. Now, substitute the length of each side into the ratio.
That's the part most of us missed, right? That whole side was 4 plus 8. So 12 is actually the length of the bigger triangle. We did that was similar too, didn't we? That was a similar triangle one.
4/12 or 1/3.
Okay. So what do you think about this one? Why is this? And this is what bothered me when you scale factor when we did similar figures. It was always the smaller. It was like the left one to the right one, and sometimes it was a third, sometimes it was 3. But with dilation specifically, scale factor is what you think it should be. How do I get from the smaller one to the big one? 4 times what is 12? So that's where you get 3 and not 1/3. Okay? All right, so that's really kind of, let's look at problem 2.
In this problem, you will find the vertices of a figure under a dilation. What are the images of the vertices of triangle PZG for dilation with center 0, 0 and a scale factor of 2?
So what I want you guys to do is we're going to take some notes on this. So I want you to get out a piece of paper, title it Dilations for me, and we're going to draw this triangle PZG. If you have graph paper, please use it. It is really what we ideally should be using here is graph paper. So it's a great opportunity to use it. And we're going to dilate the sides of this triangle. And this is something you'll be asked to do on your quiz next class as well, is take a shape and dilate it. Okay, make it smaller, make it larger, based on its scale factor. So I'll pause the recording for a minute while you guys get this picture drawn. For those of you in the back, I'll try to make them as clear as possible, but this is in fact the point 2, 0. This is the point -3, 1, and then down here G is the point 0, -2. So that should help you draw the figure yourself. All right, so once we have it drawn on our own paper, I'm going to go ahead and erase those coordinates so that the video can continue. And let's go ahead and see what happens. With a scale factor of 2, are we predicting that this triangle is going to be larger or smaller? Definitely larger. What do you think the center 0, 0 has anything to do with it? What would a center of a dilation have anything to do with the picture? Well, the center is where the point gets larger. So if it's centered around 0, 0, can you kind of visualize it's going to be twice as long, maybe centered around, or twice as big, centered around that point 0, 0? That's kind of what that's saying. If it was centered at a corner, for example, if I had something like this, and the center of dilation was here, can you visualize that it would get bigger like this? Right? This depends on where the center of that dilation is. Hopefully they'll talk about that here. But for now, we're centered at 0, 0. So let's talk about what would happen. Maybe?
Will the vertices of the triangle move closer to 0, 0 or farther from 0, 0?
We just answered that.
The scale factor is 2.
We just answered that.
Identify the coordinates of each vertex of the triangle. Point P is 2, 0. Point G is 0, negative 2. Point Z is negative 3, 1. The center of dilation is the origin. The scale factor is 2, so use the dilation rule x, y maps to 2 times x, 2 times y.
Okay? That's pretty important. So look at your coordinates and notice what they're doing. They're multiplying each coordinate, each x and y.
The image of P is 4, 0.
Okay, so go ahead and make sure that you're doing that on your own notes in your own paper, that P prime is just P with each the x and the y multiplied by 2. When the center of the dilation is the origin, that's true. But it's not always the center, so let's just figure out what the rest of these are going to look like. Can you predict what all of the coordinates would be? We'd have 4, 0. What else would we have? What would z prime be? What would the coordinates of z prime be? Negative 6, 2. Okay, and then what would g prime be? 0, negative 4. Because you're multiplying both the x and the y by that number 2. Let's see if that's what happens. Which is what we expected. All right, and they're going to find the last one for us.
The image of G is 0, negative 4. To graph the image of triangle PZG, graph P prime, Z prime, G prime.
And it is almost exactly what we thought it was going to be. Centered around the origin, just twice as big.
Triangle P prime, Z prime, G prime. Now it's your turn.
Okay. So now we're going to go ahead and look at problem 3, maybe. There we go. I don't know. Let's see what it is first. Yes, you will. And this will be the second example for your dilation notes. Okay? Maybe if it loads. There it goes.
In this problem, you will use a scale factor to find the length. A magnifying glass shows you an image that is 7 times the object's actual size. So the scale factor of the enlargement is 7. The photo shows an apple seed under a power of 7 magnifying glass. What is the actual length of the apple seed?
What do you think we'd do here? Okay, you would take 1.75 and divide by 7. You think that's right? Because it's 7 times smaller. Let's see what happens.
Relate the image length and the actual length. Since the scale factor
Just 1.75 and draw the original and see what, write the scale factor. What would it be?
is equal to the scale factor times the actual length.
You don't have to write all of that. Just draw a little seed and a big seed and decide how, and write 1.75 and we'll write question mark X on the actual seed. And let's see what they say.
Substitute.
I think they might be making it a little bit harder than what Jonathan said, don't you? We'll see what happens. Because they're going to end up dividing by 7.
Is the unknown, so use the variable P.
It doesn't matter what variable you use. So you are just going to end up dividing by 7.
What does the scale factor of 7 tell you? A scale factor of 7 tells you that the ratio of the image length to the actual length is 7. actual length, divide each
Okay.
side of the equation.
We could have figured that out kind of from the beginning, I think. It's a little bit easier than need to be for us.
The actual length of the apple seed is 25/100ths of an inch, or 1/4 inch.
Emma.
Now it's your turn.
All right, so I think what I'd like us to do is to go back to problem 2, because that's really more, oh goodness.
You will find the
I
vertical
wonder if it'll let me skip.
dilation.
Yeah, I want to try. Huh?
To
Or where do you
graph
see?
the image of
No,
the
that's a different thing.
PZ.
It's actually a different thing.
Now
This
it's
is
your turn.
this is what I meant. This is what I meant. Practice is actually from the textbook. It's actually just copied directly from the textbook, the way they did this. So I'd like to be able to look at this problem, and you don't have to copy it down or anything, but this is what the kind of example that you're going to see in your quiz. It might ask you a question like the apple seed question. If I have a scale factor and I have an actual image or a pre-image, can you find, either going to multiply or going to divide? That's really the only two different things, right? So that's one of the types of questions. Those are pretty basic. But this question here, where you're actually having to find the coordinates, is where it's a little bit more difficult. They're all going to be centered at 0, 0, as opposed to centered at a different point for our purposes, and they are centered at 0, 0 for the SOL as well. Except for that very beginning problem where they had the two triangles, right? Where it was 4 to 12 rather than 4 to 8. That was the other issue. But let's look at this one. The scale factor of 1/2, is it going to be bigger or smaller? Smaller. Can you imagine that after the dilation it will get smaller? All right, so let's decide what the answer choices are. So we want the images of P. So these are the same images as the ones you have on your paper. Okay, this is still PZG, so you still have that drawn. This time we're going to go ahead and multiply the coordinates by a scale factor of 1/2. So let's see if we're going to go ahead and try that. Look at, these are the answer choices. Look at your original coordinates and tell me what you think the answer is going to be. So look at P, Z, and G, because you have that on your own paper there. I want you to tell me what the answer is if the scale factor is 1/2 this time. I actually only had to do 1 point, and I figured out the answer. Which point did you guys do first? I did P first also. It was originally 2, 0, right? If I multiply that by 1/2, where am I? 1, 0. So what's the answer? D. I mean, that's really the only problem. It's the only one that has 1, 0, isn't it? So we know that that's going to be our answer. Let's make sure that's the right answer. And we're right, because we're geniuses. And if you ever assigned this at home, you can go to the solution page, and it would actually show you how they got those answers. Okay? All right, good enough. What I'd like to do, and that's really all there is to dilations, they're really just similar polygons or similar shapes with scale factors, which we really have already done. So what I'd like to look at is I've gone ahead and put together a quiz review for you. Let me pass it out. And we're going to look first at the dilations page stuff so we make sure we understand it because it's the new stuff. And then we'll look at the rotations with the protractor and the compass. So while I'm passing those out, would you go in the back and grab a compass and a protractor so we're ready to start that when I get done, okay? So on this, if you look on the very back, the last few problems, and I do not believe that they are numbered in the correct order. I ended up deleting some of the questions, so it does go from number 4 to number 7 and right on to 11. It's because I didn't want to make it super long, so I ended up cutting out some of the problems, and I just didn't go back and renumber them, so that's my fault. But go ahead and on the back, starting with problem 31, and again, it's not 31 problems because I've skipped around. That's where we're looking at all the dilation questions. So go ahead and try those ones on your own first for me, and then we'll look at those together in about 5 minutes. It shouldn't take you very long. Pretty straightforward questions there. So 31, 32, and 33. Any questions about those? It's literally just multiplying the x and y coordinate by the scale factor. Did you get the same answers I did? Okay. Do you agree that 37 is a dilation? One's bigger than the other? Same shape, same size? Not an isometry, by the way. Remember that? I will ask you on the quiz what the 3 isometries are, so you do need to make sure you know what those are. Why do I have a question on 38? Question mark. What don't I know? What did you say it was? You thought it was a translation? Okay. If it was a translation, wouldn't they be the exact same size? Are they? No. So it can't be a translation. Do you see that? Not the same size. One's longer than the other, aren't they? No? Am I just visually seeing that wrong? Oh yeah, they're not. It's just a visual thing with me. I just looked at that. Didn't it look like one was shorter than the other? It did for me, Gabriel. Okay, so I agree. And so sometimes you're at least with me, my vision can be deceiving. But you count. If you count vertically along the left, you have, 3 units? And vertically along the right, you have 2 units. So it is exactly the same size and shape. So what is that? It's a translation. Slide to the right and to the down. To the right, to the down, really? To the right, I think it's to the right and down. So it's 2 translations, but we'll go ahead and just write translation. So I agree there. And then what do you think about 39? Now, count again, okay, because this is one of the that right triangle has a side of 2, and the other one had a length of 3, the legs of that right triangle. And so do you see how it is, in fact, a reflection, and then it's been slid around? It's been reflected, and then it's slid? A combination of those two. So that's called a glide reflection, not part of our curriculum, not anything we're going to really worry about. So you can kind of not worry too much about calling it that, okay? But it is a reflection and then it's been slid down, okay? That's really all we're going to worry about. What I'm more worried about is question 40. Can we do it? Okay? So in question 40, I've gone ahead and graphed the trapezoid. Is it a trapezoid, by the way? What makes it a trapezoid for certain? Okay, I agree, but Andrea, explain a little bit more. I have one pair of parallel sides. I agree. AB is parallel to CD. Excellent. Okay, the other sides are not parallel. So it is a trapezoid. Is it an isosceles trapezoid? No. Okay, just a regular old trapezoid. All right, so it says that we're going to go ahead and make this with a scale factor of 3, I believe, correct? So it does say the center of the dilation is 0, 0. So I'm going to literally multiply the coordinates by 3. So if A, let's start with A. I don't have my paper in front of me here. So A is going to become the point what? -3, -3. Okay, so here's A prime. Where is B prime going to be? -3, +3. Okay, and how about C prime? 6, 6. Good. And then D prime? All right. And so it looks to me like this is going to be the figure. Okay? Exactly what we expected it to look like. All right, so if you would, so that's really all there is to dilation. It's really not a whole lot. We're only going to dilate from the center, not from a corner point. That changes the picture a little bit. You can probably imagine. Maybe that will be an extra credit question on the quiz. You never know. But it's not something that we're going to go over together, okay? So do me a favor. Let's practice one of the figures on the other side where you have to do either, let's do actually 21 together on the front. Because 20 is just like the homework problem. It's a 90-degree rotation, which you don't need a compass or protractor for. Do you see that? So it's just like the question we went over, just like number 10 from the homework, almost identical to it. But let's do 21. Okay? So in question 21, we have a triangle, and we're asked to rotate it 60 degrees. Does it tell you the point of rotation? It gives you one. It's not actually one of the corners of the triangle. Okay, it's a little bit different. And it doesn't give you a direction, so since it doesn't give you a direction, what do we assume? Counterclockwise, okay? So I'm just going to draw my picture here. You do. Counterclockwise. Now, is it a right triangle? I don't really know, but I'm going to label it triangle ABC here. And then we have point P, which is our center of rotation. All right. What do I do? Rotations. What did we do before with our compass and our protractor? What did we do? From point P. Since my center of rotation is not one of the coordinates, don't I have to move all three of them? I have to make an A prime, a B prime, and a C prime, don't I? Okay? Before, when we did the rotations, one of the actual corners was the center of rotation, so I only had to move the other two. Remember that? Now I have to move all three. How does that change things? All right, so how do I start? Which point do you want to move first? A. Let's move A. Perfect. I'm cool with that. If I want to move point A and I want to create A prime, I'm going to get my protractor out. Well, before I even do that, what do I need to do? Do I need to draw a line from there to there? So let's do that. Oh, that's not what I wanted to do. Not you. All right, let's draw a new one. There we go. Don't I need to draw that? Can you even see that color? Probably not. Is that better? Really? Trying to make it darker so you can see it. There we go. Why is that important? Why did I have to do that? Because aren't I trying to do a counterclockwise from that point? Right? That line, I'm going to line up my protractor with that. So we're going to take our protractor, and we are going to, do I want to line it up this way or this way? We're going counterclockwise. Don't I want to go this way? We're going counterclockwise. So we'll go ahead and line the bad boy up. And we're going to look at 60 degrees. So am I going to use the inside or the outside of my protractor? I heard both answers. Well, we're going to go from here 60 degrees counterclockwise. So aren't I going to use the inside? Starting at 0 and go to 60 degrees. So here's where 60 degrees is about. It's from 0 on the inside. So A prime is going to be about there. Yes, no, maybe so. Double check me. Because remember, we're going in this direction, counterclockwise. Right? Hello? Good? All right. Is that point A prime that I just made? No, remember, we don't do that. So we're going to move it. I'm going to use a different color just so we can see the difference. I'll use orange for this one. And we're going to go through there. Not meant to go through point. And we're going to, how do I find A prime now? My compass. And what do I do with my compass? I'm going to measure something. What am I going to measure? The length of what? P to A. Very good. So we're going to measure that. Once I have that measured, then I'm going to come on my orange line, make an arc, and I have now created A prime. I have to do this with all three of my points, okay? So now we need to move C prime, or make C prime. And we'll have to do the same thing with B prime as well. So I'm going to do it up here. Or do you want me to give you a chance to try it on your own first? We only have about 15 more minutes. So I'll wait for like 2 minutes, let you guys practice, try it on your own, and then we'll make it bigger. Are the compasses is the figure too small? It's a little hard to do. Try to make your pencil lead, if you need to, a little bit longer. If you unscrew on the compass and kind of elongate that pencil lead, sometimes it'll help you because it won't kind of bend in on itself. You can try that. All right, so hopefully you guys got it. Let me go ahead and move point C. If you want to go ahead and look and see how I do it, this is your chance. I am going to go ahead and draw the line from P to C, or through C. It's very, very close to the orange line that was already there. We'll go ahead next and line up our protractor in this direction so that it is along the green line. We're going to go out to C. So C is going to be, or I'm sorry, we're going to go out to was it 60 degrees we're moving it, right? So 60 degrees is going to be somewhere about here. And we'll draw our line from P through here. And then we'll measure the length from P to C. And we'll make it on here. So this is going to be now C prime. And we still have to go ahead and move point B. By moving point B, we're going to do the same thing. We're going to go ahead and draw a line from P to C. I'm sorry, P through B. There we go. And then we'll go ahead and line up our protractor along that edge. Oops. There we go. And we're going to go ahead and go out 60 degrees, which looks like it's about right here to me. And then we're going to draw our line from P through that point. We'll measure it. All these little lines everywhere. We'll measure from P to B. There we go. And we'll make an arc on here, and that will be our B prime. So to go ahead and connect these, we'll connect them. I'll go ahead and connect them with a dotted line so we can kind of see A prime, B prime, and C prime. And this is now our rotated triangle. Did you guys get that? Something along those lines? Sometimes it's easier to see if you go ahead and fill it in. So I'm going to go ahead and fill it in, highlight it so you can kind of see there's lots of lines that are going on. So that's fine. Yeah. But as long as you can really truly distinguish, because all those extra like orange and green lines I have drawn up here are a little distracting sometimes. So that's why sometimes the coloring it in helps you. It is not necessary to do that with problem 20 because you can literally just rotate it. Make sure that you're rotating it on itself though. Make sure that the center of the rotation is still P. So they should be overlapping rectangles in number 20. Does that make sense? And make sure you're labeling how the vertices changed. What would I prime, F prime, G prime, and H prime be? Your homework is to finish this practice for yourself. There are some other things that I would really want you to pay attention to. What happens to the point x, y when I reflect across the x-axis, when I reflect across the y-axis, the line y equals x, those notes we took before. So make sure that you're looking at all of that, and that will be your quiz, and we'll take that on Monday, okay?